Assalamu alaikum and welcome back to this channel. And today we are talking for chapter number 6 of our book, that is Detail in Detail, edition number 9. And our today's topic is related to arrays, and this is a very important topic where we are actually going to introduce arrays today, and we are going to do some examples. This is a slight overview in front of you for the chapter number 6 over there. We are going to talk on the introduction to arrays. We're going to talk about how you're going to have the basics of an array, how it's going to be initialized, then how some examples as well, then how you are going to have the character array and strings, how you are going to store a string or an character inside an array over there, how you're going to pass those arrays to functions, and then the sorting and the searching over there. Today we are going to talk about bubble sort, a very important algorithm, and then a linear search. We are going to do that, and then most probably in the next part I'm going to talk about the next part, another video I'm going to talk about the two-dimensional array, and then of course we are going to do some solved examples and some common mistakes and all that stuff. And then just to give you an idea before I even start this thing, why arrays? Up till now, we have made data buckets or variables that have been of different data types. Supposedly, they have been integer, they have been float, they have been character, they have been double, or they have been boolean up till now. Arrays are something when the number of variables which you want to store data is very large, then the word array comes. Now, supposingly, if you have went to some parking slot inside some mall or inside some stadium or somewhere, the parking slots are numbered. They are not given a name over there. For example, supposing you go in some plaza, in some underground parking, and you are given a ticket over there, and you are told that, okay, that particular slot is open and you have to park your car there. That slot has been numbered. So that numbering is actually the important thing. So arrays are based on numbers with a target name and then a number over there. So if you have been told to park your vehicle in only the slot number 90, then you are going to have the slot number 90. Of course, there is going to be some feedback system to the person who is actually going to issue this. Okay, that slot number 90 is empty, so you're going to get your car parked over there. So he will issue that ticket over there, and when you are leaving it, you will be actually giving your payment and all that, and you will be leaving, and then this means and the 90 slot is empty. So here the slots are numbered. So if the data is much more, up till now you have been using 2 3 variables, 4 variables, in which you had an x y z a b c d or something like that, and that was something very easy. So you had simple 5 or 6 variables. But supposingly you want to store something more than 10 variables or more than 10 data types over there, then of course then you need arrays, and those arrays are numbered. Remember, the numbering of such a data bucket always starts from 0, and it goes on to up till whatever your number of array you require, that is going to be. Supposedly if you want a 10 length array, then you are going to have a numbering start from 0 to 9. So let's just go on this one. So array, it's a group of elements of the same type. Now this is something very important. So if you are going to store integers inside your array, it's always going to be integers in all those 10 slots. Of course, in a parking lot, you can only store a car, a four sedan or something like that. You can't park a truck inside that. So of course, there is only going to be one data type over there. So arrays can have, or it's a group of elements of the same type stored continuously. Now, this is something very important, one after the other. So if you in your RAM or in your memory, you are going to store your data, and if it's an integer, that integer is supposedly going to be of 4 bytes over there. Then you are going to have, supposedly you are going to have like 10 slots of there, and those 10 slots are going to be stored consecutively. So if your numbering is stored over there as 0 cross 0 0 0, supposedly is the first one, then 0 cross 0 into 0 0 0 1 is going to be the next hexadecimal address of your memory, where your next array number is going to be stored. So you can think of it, just an example as written over there on this slide is this. I think of it like a row of mailboxes for apartment building. Supposedly you have some mailboxes over there at the outside of a building. Of course, they are numbered according to your numbering over there, just like your houses are numbered according to some numbering over there. If your house number is like 315, or it's like something 123 or 345, whatever that number. Similarly, a parking lot with numbered spaces, as I just told you in the very start, or a row of lockers in school. Now, nowadays, lockers are also there inside schools where you can actually put your belongings or your stuff or your books over there. So it's just like an group of elements of the same type stored. Remember one thing, they have to be of the same data type as shown over there. It has to be the same data type. And elements are stored consecutively, which means that they are stored over there, and they are static, which means their size is fixed. So you have to tell at the very start when you are declaring, just like you declare int x is equal to whatever value. So you are declaring that x is an integer. So similarly, when you are declaring an array, you have to tell that what is the size. So you have to tell that what is the parking size of this parking plaza. So if you have 500 cars inside it, so you can only have from 0 to 499 numbers over there. Now, what is this the numbering over there? Let's just go on the slide and I will tell you what this means over there. Now, just a little slide to tell you that why do we need arrays. I told you if you can't have more than like one or two or three variables. So if you want to have, like, supposing this is grade 1, grade 2, grade 3, grade 4, grade 5, and you want to store supposing like up till from grade 1 to grade 20 over there. So this means you have to make 20 variables. Now that's a very difficult thing. And if you are going to address those variables, you need every time a new command. To solve this problem, you can have arrays. And for that purpose, this procedure is very simple. The data type remains the same if you have int over there. The word grades define the name of that array, and inside this strong brackets over there. Now these are the not curly brackets or parentheses. These are simple rectangular brackets over there, and inside that brackets over there, rectangular brackets, the word 5 is given. Now you have to always write a number over there, a digit over there. So if this is 5 written, so this means that this is an array of integer data type, and it has to store from 0 to 4. So this is 0, 1, 2, 3, 4. So this is 0, 1, 2, 3, 4. And how you can actually put some data inside it. So this is grade 0, 85, grade 1, 90, grade 2, 78, grade 3, 92, grade 4, 88. So you can have now in this way, even 20, even 200, whatever the number of data you want to store inside this integer array. Now remember, this is integer, so it can only have integer inside it. If you want to store float, then of course you have to make it float, and then it will be 85.00, whatever you want to store inside it. So this is actually the main mug. Now coming on to the array structure over there, as I told you, here if you have an array of like 5 length, the length is 5 over there. So the first element is always going to have a number 0, and that is called as the index. Just like for a parking lot, you have a ticket number that, okay, you are going to park at supposedly at slot number 0, slot number 2, slot number 5, slot number 80, 90, whatever. So always an array starts, the word used for this is index. So now I'm going to use the word index from now on. So if an array, the index always starts from 0, and it will go up till the maximum length minus 1, because you're starting from 0, so you have to go up till 4 here, because this is a 5. So this is position number 0, position number 1, position number 2, position number 3, position number 4. And since these are integers over there, and the array name is C, so this is C, brackets open, rectangular brackets, that's 0. Then there is a C, bracket open, that is 1. Then there is 2, there is 3. Now, whenever you want to store some data, and supposedly that data is coming on from some for loop or while loop or somewhere, so instead of this 0, you can just put a variable number, supposedly x, y, and that x is changing from 0, 1, 2, 3, 4, 5. So in this way, you don't need to write down 5 different commands. You just need to use a variable as its index, and that index changes. You store the data whenever it's coming in. But of course, you should know that how much data is coming. If you don't know how much data is coming, then you cannot define your array as a dynamic. Remember, I have told you that arrays are static. They are always static, so size is fixed. So you should know that what should be your size. You can't make it like supposedly you have declared your array as supposedly as 20, and then afterwards, okay, you say, okay, no, I want have supposedly 22 numbers inside it. No, you can't do that. Then you have to make another array, copy the previous element over there, and then discard the previous one. That is one way of doing it. Now we will come back to it as this chapter ends. At the very end, I will tell you how you can actually do that thing also. But at present, they are static, you can't change it. So always array indexing starts from 0, not 1. Remember, this is very important. For an array of size n, valid indexes or indices, since index is the singular, so indices are from 0 to n minus 1. So if you have declared your array as something as int grades 5, so it will go from 0 to 4. If I supposedly as grade 50, inside you have written 50, so this means it will go from 0 to 49. So this is one way of doing it. So arrays are something like this, where you have to actually have your indexes defined. Now, how you are going to define it? And I have already told you, you can define an array by the data type which you want to store. First of all, just like you declare variables, int x, float y, character x, whatever you want to declare. So first of all, the word is the integer, float, double, character, whatever you want to store over there. Then the word of the name of that array. Of course, there is a parking plaza, but that parking plaza has a name. Either it is some mall somewhere at some other location, some mall number 1, mall number 2, mall number 3. So here the word used is C, and inside brackets, these are, again, remember, these are not the curly brackets, these are not the simple parentheses, they are simple, strong, rectangular brackets, we call them. This is just beside the P on your keyboard over there. So you have to store inside it the value or the length of your array. This is the length of your array. So this is a C array with a length 5 and the data type is integer. And here, this is an array of grades, name is grades, and it has 100 length over there. This is a character, so this means it is going to store either A, B, C, D, whatever, or a character inside it, and it has a length of 20 over there. Now, how you are going to access it, it's a little cheeky over there. I will tell you a little later on. Then afterwards, float, it has the name temps and it has 7 floats inside it. So its indexes will be from 0 to 6. For this one, it will be from 0 to 19. For this one, it will be from 0 to 99. This one will be from 0 to 4. Remember, if you will try to save a data at somewhat at C5, that is not going to be allowed, because the array is of length 5 and the last index is 4, because it starts from 0 and ends up till 4. So when you write down this integer over there, the computer allocates space for, the compiler actually does this, they allocate space for 5 integers. Now, since one integer is equal to 4 bytes, and I hope you have an idea up till now because you are doing this programming and in parallel you have other courses as well. So you know one integer is equal to 4 bytes and 1 byte is equal to 8 bits, just to give you an example. So you have 5 integers, so this means 5 into 4 bytes, 20 bytes of data will be allocated inside your RAM or inside your main memory. So this reserves consecutive memory locations and it does not initialize. Remember, whenever you are writing down this name, it does not initialize anything. It has garbage value. So just like a hard disk which is empty or something like that, we can't say it's 0. Maybe it has some previous data at that RAM location, maybe 1, maybe 0. So it's garbage. That's why we call it as a garbage data. Now, whenever you want to store some data inside it, remember, you have to use this again with the index name inside it, and you have the since this is integer, so you can only store an integer inside it over here. So C2 30, C3 40, C4 50, and here you have missed C1 over there because we have not assigned it. You can do that one as well. Now you want to give that value, you want to print that value, you can do that by printf, and here this is the format specifier percentage %d, and you have that C0. So what will happen? C010 will be printed. Now you can even use the array inside an equation. Supposedly you are taking an input from the user and you are storing those values inside your array, and supposedly they are like 5 or 6 different values. You want to add those arrays. This becomes very easy. Previously you have been taking, like, you have to have like 5 numbers, x, y, z, a, b, c. You have to take 5 numbers. Now that problem is going to be solved. Now you only need to have an array which is going to have from 0 to whatever the length of your array is -1, because index always go from 0 to n minus 1, where n is the length of your array. So here int x is a variable, is equal to C2, that is C. Now, when I'm using the word C2, this means that C is an array and 2 is the index of that position. So whatever that C2 is there, so that is 30, and then there is C3, so 30 plus 40, 70 will be there. So X will be having 70. And similarly, now C1 can be put as C0 plus C4. So you can use your array for taking the data, or even you can use it for storing a data from another location, but of course the data type has to be same. So this is something very important. Now remember, inside this one, as I told you, if you are going to use C5, it will not be access and it will be giving an error. Why? Because C is an array of integer data type that is going from 0 to 4. It will not having a 5 location. So this is always going to give you an error because the valid indexes or indices are from 0 to 4 only. Now, one small question, I guess you can easily answer this. Which of the following statement is false? Now let's see that. An array element may be referred to by giving the array's name followed by the element position number in square brackets. Of course, this is true, totally true, because you can actually refer it. Every array's first element has a position number 1. Wrong. It has 0. Remember, it has 0. Next thing, an array name can contain only letters, digits, and underscores and cannot begin with a digit. Of course, that is exactly true. Just like an array name can contain only letters, digits, and underscores and cannot begin with a digit. Of course, just like an integer name or a variable name up till now, this is exactly the same. The position number in square brackets is called the element's subscript or index. Exactly. This is true over there. So only false, I guess, is this B statement over there. And then going on again, a self-check question: which of the following statements, I guess, only B is false. I guess they have given the answer over there. The B is false. Every other variable has to position from 0 or not 1. So only B is false. The remaining A, C, and D, they are true. So we have just done it accurately up till now. Now, coming on to example. Now, I want to show you this example over there. And let's see this example. I have this chapter number 6 example from the book downloads over there. Now, you can see over there what I have done over there. I have the included over here, and here I have used on line number 4. Now this is something very important. See this thing. Now the word define is new for you. Now what does this define you? Define, and there is a word written and then there is 10 written. Now what is this telling me? This is going to tell the compiler that whenever I use the word size in caps lock, of course, then it is to be replaced by this value. So it's just like defining permanent values. This is define over here. The word define, hash mark define, defines a permanent constant value for your program. So if you know size is going to be 10 over there, let's say I want to change something. Let's say I want to define pi equal to 3.14159. What it will do whenever I will use the word pi. Now I can't use the word pi for any variable now. Remember this thing. This is very important. So you are defining constants over there. Just like you have to define pi, you have to define mu naught, you have to define epsilon naught, or you can use any other variable. So here the word size has been given. Again, this is alphabetic, caps lock over there. It's not going to be small letters over there. So it's going to be replaced by 10. So what is going to happen? You have a function prototype, just like in chapter number 5 over there. This is a function of integer data type. What is this? Is the function name, and inside it you have constant integer. B is the array that is going to come inside it, and here you have size underscore t p over there. So this size underscore tp is a function prototype over there. Now let's see what it does over there. See this one. You have an integer over here. This is the main function over there, and below there is the function definition over there. Now let's see what it does over there. Inside the main function, I have an array, and that is int a, brackets open, that is the rectangular brackets, then there is a size, and equal to, I use the curly brackets to write down the data for 10 array positions. So this is 1 2 3 4 5 6 7 8 9 10 separated by comma. And you can see whenever I'm using the mouse over there, the Visual Studio is giving me the output over there. So this is integer 10. It's an array, and you have over here the 1 to 10 over there. You can see the answer. Now I declare another variable x, and then I use the function what is this. So I am actually going to put inside an array. I'm passing as a parameter a whole array. I'm not passing a value. Remember, I'm passing the whole array. What is a? A is a array of integer data type which is going inside this thing, the function, and then there is size. And what is size over there? Size is over here a variable or the constant defined as value 10 over there. Then printf, result is x. Now what is this going to? Now let's see what the function does. What does this function do? You have to tell me also during this one. Integer, what is this? Again, same thing, same the function prototype name and then the function. Now here, this is the base case. So this is actually something like a recursive function. So if p is equal to 1, so if this p is equal to 1, this means this function is equal to 1. So this is 1. If this is 1, then return b0. So what is b0? B is this thing that is 1. The answer is 1 over there inside the b0 location. So 1, this is going to be done. You are going to have 0 returned over there. Then else return b p minus 1 plus, what is this? B comma p minus 1. Now what is happening over there? You are actually calling a recursive function again and again, and that is going to return b0, or it's going to return b p minus 1 plus, what is this? Supposingly you have entered over there inside this function, you have written this thing and size is equal to 10. So what it will go, when it will go inside this function, p is not equal to 1. Of course, p is not there as 1, it's 10 at present. So what will go, it will go inside this else block. Now it will return b p minus 1. P minus 1 is now 9, so this will be b9 plus, what is this? P9. So now another function, a recursive function, is being called. So practically over here, let me just write it down over there. So whenever this function is going to be called, so this is going to be calling over here b brackets open. This time it will be 10 and 10 minus 1 plus this. Then this will be b plus this. Then it will be sorry, on this one I have to write it down like this, and then this will be b plus this. I hope you are getting what I'm doing over there. Plus over here like this. So this is b brackets open, and now you're getting it. So this process will repeat on when you are going to have up till, let's say I have this thing, this is going to be b6 actually over there, and like this, and this process will go on when 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and the last base case would be this b0. So what is going to happen? X is going to return the values of this plus this plus this plus this plus this. So whatever inside is in the array, they are going to be added up together. Let's see what happens. Let's see. Let me just open the new terminal over there, and I just turn on. I don't know why my debugger is not working, or I guess okay, my debugger is there. Okay, I have the result is 55. You can see. Let me just again run it. I guess I actually have to. So result is 55. What is 55? 55 is the sum of this 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Let's say, just to give the answer, let's say I change it to 0 and I run it. Now this time it should be 54. You can see it's 54. So what you are doing, you are passing an array as a parameter inside it, and that parameter is actually being summed up every time in a recursive method. So this is b10 minus 1 plus, what is this? B10. So this one is actually equal to b9 plus, what is this? B9. And then afterwards b9 plus b8 plus this thing plus b9. So at the end of it, let's say after a lot of dot, and afterwards this becomes equal to b, and it will be something like this. And afterwards, let me just add it over there. This will be b6, and it will be, so this will be something like this. I've just skipped that dot because I don't want to put it that over there. So 5, 4, 3, 2, 1. So how many times this else statement is going to run, or the statement of the recursive is going to run? That will be approximately 10 times. Why? Because this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10. So this will be the addition. So here this is a very classic example of passing an array as a parameter, and here you are having that p giving you that how many times you have to actually run it. So you have to actually tell it over there. So if I just change it back to 1, let's say, and I just again run it, again the answer would be 55. So I hope now you are getting what I am doing over there. So this is a very classic example of having recursion also and using arrays over there. Remember, this is an array, and here this define is defining the size, or if I have defined pi over there, you can do that one as well, totally up to you. So here this is going to be that array over there. Then another example, I guess I have another example over there. In this example, what is happening? Let's see this in this example. What is happening? Again, same thing, size 10. Here the number is a. The function is sorry. The array name is a. Again, 831260974 5. It's randomly numbers over there inside. It's an integer character integer array. Then you have puts. Now, what is puts? I guess I don't need to tell you. Remember it over there. So now when this is puts over there, the answer is, and then the function is called that is over there. Puts is always automatically going to put that backslash n over there. So you have the sum function a comma 0 comma size. Now what is this? A is an array. What is 0? 0 is over here the starting, which means from where you want to start your array, and the size is that the size of your array. So here you have 10 values inside it, so you are putting in 0 size. So when you put it inside over there inside this function, let's see what is happening. If you have a start function, if start is less than size, of course when start is 0, size is 10 over there, then inside it again you are calling the function, and here you have b comma start plus 1 comma size. So b function is exactly the same, start plus 1. Now since you are changing it to 0 plus 1, so it's now 1, and then size is still the very same, that is 10 over there. And then you are printing over here. Remember, this is printing over there every time over there, and you are starting with b start. So whatever your value of 0, you are going to have 1 printed, then you are going to have 2 printed, then you are going to have 3 printed, 4 printed, and this will continue to go on because this function is again called over there. This is b start over there. So what will happen? This will go on up till this condition so there is no need of any base case. Automatically base case is being done because here you are doing start plus 1. Remember, you are doing start plus 1 over there. So before this printf function comes on, you are actually calling the function itself again. So you call this function over here at this point. Supposedly you call this function as, this was some function, and this was called as b0 plus 1 comma 2. So it will be called, and again that function instance will be created over there, and then again it will be going on. So after some time this will be some function. Let me just write it down. So again when this function will be called, this will be b 1 plus 1 comma 10. So when this function will go up till 9 plus 1, when this will be called, then this condition will be violated, then this will stop. So when this will be stopped, then we will start to print the values from 8312609745, and the answer is, let's just run this one, and now you can see over there. So this you have 5479061 over there. So you have the values over there that are being printed over there. So this is b start printing over there. You have the values 5 4 in reverse over there. Remember why reverse? Because you are having the recursive function. This printf function, the first what will be printed, it will be printed of this function, the last function, because remember, this function or this line number 22 is not going to be running unless and until all those functions have gone through it, because that function is going to be called first. So the first time, the start value will be having 9 inside, that is the last one, this one. This will be 9 over here, so that will be 9 will be called. So that's why you are going to have 5479. So you have 5479 over there, and then afterwards you have the over there. So you have the simple answer is over here, and then you have the over there. So you have everything in one line. Now you can make that one totally up to you. You can make even that as backslash n over there if you want to put it in like vertically lines over there. So you can see have 547906213. Totally up to you if you want to put this fraction. The puts is already doing it because the answer is in one line. So answer is, and then backslash n, and then afterwards this all are printed, and then again a backslash n by this statement over there. So you have this function over there. Again, this in function, you are now calling the whole array, and that array is being having a start and a size over there, and that start and size is being printed over here as this value. So this is again a very important example, and let me just show you another example over there, and another, then I will go back to the slides over there. And that's a very simple example. Now this was an exercise problem, we have just done this too. This is the problem given in your book over there, you can go through this very simply. Again, you are having an array that is n, and that n integer, n is an array with 5 locations, which means from 0 to 4. Then you have a for loop, and inside that for loop you are initializing set element at location I to 0. So every value from 0 to 5, you are going to run it from 0, 1, 2, 3, 4, and every value is going to be having 0. So here you initialized it, or sorry, you declared it, sorry, and here you are initializing it to 0. Now, then afterwards, printf, you are having a table, and that is percentage s string, percentage s, and that is 8 tabs over there, and then you have the backslash n over there, then you have the element, and then you have the value. Then afterwards you are now printing the value for this thing, for size I equal to 0, and this is I less than 5. So again this loop is going to run from 0, 1, 2, 3, 4, and this time you are going to print it. So now when I'm going to print it, it's just going to have 0, 0, 0, 0, 0 printed, nothing fancy over there. So you can see very easily. So you can see over there 0, 1, 2, 3, 4, 0, 0, 0, 0, because I have initialized it to 0. Now if I make it look supposedly equal to 2, all the elements will be equal to 2, 2, 2, 2. And I guess I don't need to tell you that why this is 7 over there, because this is 7, because this is 1, 2, 3, 4, 5, 6, and then 7 over there. So at 7th position you are printing it. That's why it is percentage 7 over there. And then afterwards you have that as percentage 8 over there, because here this is 8 values, afterwards this is 2 is being printed over there, and then a backslash n over there. So this is I, and there is the array which is being addressed by n, and inside there is I, and since I is going from 0 to 4 here, because is equal to this one. Now supposingly, let's say if I equal to, now this is going to not print anything. Now let's see what happens. When I do this thing, you can see what is happening. It prints that 5, because of course I is 5, but here this is empty. This is a fake value, because it's going to that memory location, but that memory location is not an array. It's just a garbage value stored over there. So you always have to run your array whenever you are addressing an array, or storing an array, or accessing an array. You always have to make it from 0 to this one. This always, arrays always have to work from 0 to that index, that is actually the length of your array minus 1 over there. So this will be then like something like this over there. Coming back to the slides over there, again this is a very same thing, we have just done it just now. Over here you can see over there exactly using loops over there, same example over there. And then I have the initializer list. You can initialize it by using this curly bracket. So this is a 5 length array, integer type. Here this is a 5 again, but here you are having only 2 elements. What this was, you places at 0, 10, places at 1, 20, and the remaining ones are 0, 0, 0, 0, 0, because they are empty. Yeah, they are empty. Quick way to initialize all to 0 is this, that you make it equal to 0, all elements become 0. Now this is one way you can do it. If you want all of them to be 0, then you can just put it. So here, this is another way of defining an array. That is, here you don't write down a number inside those rectangular brackets, and you write down 1, 2, 3, 4, 5. So size automatically becomes equal to 5, because you know the values are 5. The compiler does it. The compiler will count it and give the value of this array, which is name is q. It will be having an index from 0 to 4 over here, or actually 5 length over there. Now here, if you do something like this and you put it something like this will be an error at the compiling time. So this will give you an error, because here you have put 4 values and here you have 3. So practically it will only go from 0, 1, 2, but here you have put a third index as well. That is wrong. So that is going to be. Then next thing, very important, here again using symbolic constants. Now let's see what is happening. Again, I guess I have already told you this thing, the size defined. This is a constant, as symbol that has been defined over there. You call it as a symbolic constants over there. I have called it as a simple constants over there by the word define. So size is a constant, and that is being defined as 5. In our example, as I showed you over here, that was having in this example. Let me just go back on there. That was just 10 over there for this example, or it was also 10 over there. For this one, we have not defined anything. So this is again a way of defining a constant over there, and that constant over here is this 5 in this case. So here int s, so this means here this statement will be making all the 5 elements, which means from 0 1 2 3 4 will be having 0 over there. And here now you are having filling the array with even numbers, that is 2 4 6 8 10. And how you are doing it, you are having an for loop going from 0 to, of course, 4, because 0 1 2 3 4 it will run up till that time. And then you have 2 plus 2 into j. What is j? J is equal to 0, so 0 into 2 will be 0 plus 2, so the first element will be 2, the next element will be 4, the next element will be 6, the next element will be 8, the next element will be 10. So in this way you are putting even numbers inside your array. Then you can print your over there as well. So and then this array, you are printing it over there by using your printf statement, and again the same way that we have done over there previously. So you are actually putting it over there inside this process. So this is using a symbolic constant. You have already done it over there. Then I guess kindly try to do this one yourself. Write a statement that displays the int product of the values contained in the first 4 elements of the int array grades. So try to do this thing yourself. I'm not going to do this one over here. Maybe in the next class, in the next one, next part, I'm going to do a lot amount of coding over there by hand. So we will talk about that one later on. Again, another question, I guess they have already given the answer. I guess I don't need to ask you. It's very simple. So you have written a statement. So you have to have grade 0 multiplied by grade 1 into grade 2, because all 4 are integers. So you don't need to write down. So you have int array over there. So you just need to multiply, 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 because all are integers. So just need to multiply it, and the decimal number is going to be displaying as a format specifier. So the first 4 elements are 0 1 2 3. Multiplication operator we already know is the asterisk. So array indices go inside the square brackets. You can do it. Now, if you want to make it dynamic as well, if the numbers are changing, you can do that one using your for loop also over there. So that is also one way of doing it. We will do that one. Then I guess we have already done this one in the example. You are having this 1 2 3 4 5 over here. Again, it's a symbolic constants over there. That is size is the word, and that size is being used over there. We need to find out a total of all these elements. So we have a for loop, and here you are doing this total plus equal to, which means you are every time adding the array elements. That is a bracket I. So I over here 0, 1 will be addressed, so it will be added to total. Then next time for loop goes, 2 will be addressed, then it will be going inside, then it will be 3 added over there. So 1 plus 2 plus 3 plus 4 plus 5 will be added all inside per total, and that total is going to be printed, and that will be 15 over there, because 5 plus 4 9, 9 plus 3 12, 12 plus 2 14, and 1 15 over there. So this is a step-by-step total, very simple one. You can find out the maximum as well. Now this is something very important. You can find out the maximum. Supposing you have an array. Again, symbolic constant is 5. You have 45, you have 23, you have 89, 12, and 67. Now this is something very important before we move on to the bubble sort and all that. Sorry. So assuming now again what you are doing over there, you are taking a number variable over here, sorry, not number, a variable, and that variable is equal to number 0. So assuming it that the first is maximum. Now this is something very important. You are assuming that your first number is maximum, just assuming it, and we are going to compare this value with every other value and find it out, okay, is this right or wrong? So for that purpose we have to have a for loop, and inside that for loop has to go from 1 to the size. What is size over there? Size is 5 over there. So by we have to start it from 1. Why? Because already 0 we have assigned it as the maximum. That is the point. So if number I, so numbers I is greater than max, which means what you are addressing this 23. If 23 is greater than 45, no, then this statement will be run. It's not true, so it will not be done. Then again, it will go on to 89. Next number for loop. If 89 is greater than 45, yes, this is true. Then what will happen? Maximum, that is a variable that will be taking the value of that number I. So if 89 is greater than 45, that 89 will now go inside the max, because that is greater than that 45. So max will now be 89 for all other values. Then afterwards, after the 0 1 2 3, the third one comes number I. What is 12? So is 12 greater than 89? No, this will not work. Then again, next iteration 67. 67 greater than 89? No. So this means at the end you just have to print your max. That is going to be the maximum value. You are not sorting out anything. Remember, sorting out an array would be something like this, where you are going to have 23 here at the same position, 12 coming on here, then 45, then 67 and 89. That will be sorting out, which means you are going to arrange your array ascending or descending. That's a totally different thing. But here I'm just trying to find out the maximum. So that is the maximum value which is being printed over there inside this printf statement. Then this is a very simple histogram or a bar chart. I guess we have done already over there. So you have the printf, the element, then a tab, then value, then bar, and then chart over there. So you have again an array of size 5, which is going from 0, 1, 2, 3, 4. So here even you are going to inside a for loop, and inside a for loop you have the printf into I into an I over there. So you are printing that number and that value. You are printing that number. So at 0, 19 will be printed, at 1 3 will be printed, at 2 15 will be printed, at 7 sorry at 4 sorry at 3 7 will be printed, and at 4 11 will be printed. This will be done by this thing. So every time this is being done, and inside it you are going to have the statics printed over there. Now this is actually going to print how many values are there inside it. So supposingly you have taken that value of I, and that is 19. So what will happen? You are starting another for loop, and inside that for loop you are going to have your loop run from 1 till the value which is inside, stored inside. So it is 19, so this will be 19 over there because you are accessing 0. So this will be j less than 19 plus plus j. So what you are doing over there, you are going to printf 19 times. When this comes, 3 times. When this comes, 15 times. When this comes, 7 times. When this comes, 11 times. So in this way you are going to have your histogram. So for every value of 19, 3, 15, 7, 11, you're going to have the respective statics printed over there, and the loop finishes, and then you are returning 0. That is the main function over there. So this is just like a histogram or a bar chart over there. Another example, I guess this is the output over there, is the element value bar chart. You have the 0, 1, 2, 3, 4. You have 19, 3, 15, 7, 11, and you have this 19, there are 3, there are 15, 7, and 11 over there. So how it works, the outer loop goes through each array element. The inner loop prints static. As I have told you, this inner loop is responsible for printing those statics over there. Already you are familiar with the patterns and all that we have done in the previous lectures. So we have an idea. So for n0, this is 19, the inner loop prints 19 statics over there. Then very important, before I finish off this one, whenever you want to store character arrays, now this is something very, very important. Now see this one very carefully, because this is going to be very important for your next chapters on so on, which we are going to discuss a lot. Now there are two ways to initialize the character array. Okay, the first one is you store character string 1 is the name, and inside it you are not going to put any value, and here you put first. What it does, it stores at each one location. So at 0 f will be stored because this is a character array. Then at 1 I will be stored, then at 2 R will be stored, then at 3 S will be stored, and then at 4 this will be T will be stored. So now this will be a 5 one. Now in character, to tell the compiler that okay, this string is complete, you have to add another one which is called as the null terminator, that is \0. We'll talk about this later on when we talk about in chapter number 10, when you're talking about the formatting input and output over there. Then we will talk about this a little bit in detail, but at present your character array by default always going to have this \0 as the null terminator, that is telling the compiler okay, this is complete. So by default, a character array will be having your characters plus one null terminator. So the size of a character array is always going to be one more than what is defined inside an integer, a float, or any other type. So this is something very important. And if you want to define it something like this, totally up to you. If you want to define it something like this with this thing, brackets, curly brackets, and inside you have single quotes, F, then I, then R, S, then T over there. Now what, this is exactly the same thing. The only thing difference is this, that here you are having 0, 1, 2, 3, 4, and this is 5 over there. Remember, this one is not printable. This is not printable. This is \0. This is not printable. This is just telling the compiler that this string is complete. It is the end. This is a null terminator. So it's terminating that string or that character array over there. So that's why its val size is equal to 6. Now, how you're going to read and print this string? Now, this is something very, very important. Now, here, if you have, again, a symbolic constant 20 over there, you have a character name size. So you are defining a character array of name over there. Actually, the name is the name over here also, and size is 20. So this means this is going to have it. You are asking the user enter your name. So here you ask the user by scanf command, and here you have written. Now this is something very, very important. Now see the statement percentage 19s. Up till now you have not been taking any character input from the user up till now. In the last 5 chapters, you have not been taking any character input. Always you have been taking numbers or something like that, or maybe -1 or -2 or something like that. Always numbers. First time you are taking the input of a character. So here you are going to have this 19. What is this 19? 19 is telling me that this is the maximum characters that you can enter. It includes the spaces also. Please remember. And here you are not having that and symbol also. This is something very important because name is a array and you are now, so when you are going to put this inside this name and you are going to print f, and here you are going to have percentage s exclamation mark backslash n, you will be having your name printed over there. So when you are going to have it for a 20 character array, you can only read 19 characters, leaving room for one null terminator. This is something very important. And always use the field width. This one is percentage 19s. 19 is the character values which you can enter to prevent buffer overflow. Why prevent? Supposingly someone has a name something like Bu Ali Sina Ibn Khattab and something like that, and that is something going on up till like 25 characters, then that will not go inside it. So it will be a buffer overflow. So what will happen? It will truncate either the initial ones or the last ones. So to avoid it, you are telling the compiler that, okay, you only have to take the first 19 ones over there. So to avoid it, you are taking the first 19 characters and save them inside the name array that is named over here, and it having at size 20. But again, the last one is going to be the size of your the null terminator over there. Similarly, you have to access individual characters. Now you can do that one as well. Supposedly you have saved it as hello, and now you want to print h separate, e separate, l separate, l separate, o separate. So again, a for loop. So what you are going over there, you have a printf percentage c. C here stands for character, not string. Remember here you are having string printed, so that was it for percentage s over there. Here this is percentage c, so this is percentage c, and here you are having word and in brackets I. So what will happen? 0 will be printed, that is H. 1 will be printed E, then L, then L, and then O. So this will be printing on. So the output here will be hello. So this will be hello printed over there. Now, supposingly you modify one. So instead of hello, you make it instead of H, you take it J. So now again, you are now going to print F with percentage S. Remember, this is percentage S. Here you are having percentage C character. So this is a little different. Here, when you output it, this will be jello. So you can address one alphabet. Now, I guess now you are getting the point that whenever you are going to change or store a string inside a character array, you can change individual characters or your whole name if you know the first full name and the spacing over there. That will come on in chapter number 10 when we're talking about formatting input and output and characters and string. There's a whole chapter on character and string. I guess chapter number 9 over there. We're going to talk in detail over there. But at present, I hope you are now getting the idea that the point of actually storing all the alphabets of a character or your name or whatever inside an array, because each of the character is now being addressed by an individual index. So if you want to supposedly change the father's name at some point, or maybe you want to have to change, if you know, okay, the one some person has supposedly entered a 19 digit or 19, sorry, 19 length of your name, having your first name space and then last name. So you know where space is, truncate everything beyond the space and replace it with your name. So that you can also do over there. So this is something very important, that putting them inside an array Now you know that how you are actually going to change your first name or last name, or maybe supposedly you want to change, or you just want to take out the first 5 letters, maybe you want to take 7 letters. That's a totally different chapter we'll talk about in detail. But just at present, whenever you want to print characters, use percentage %c. Whenever you want to print string, percentage %s, and here you are going to just give the whole name of your array. Then it's, remember, if you could see over there, then you have to give word and the rectangular brackets just like this one, so that you can print individual address character at each location of that array. This is the individual characters over there. Remember, I guess I have already told you, whenever there is a function, you have to pass on that function, and in that you don't have to write down its length over there, because you're just passing on the function array, and that is that array integer, and array is the name, brackets, that's telling you that okay, this is there. So here you are just printing on over there, and this is adding up all everything. So you're just printing on the arrays over there, and this function is being printing the arrays over there, like this thing. And remember, whenever an array is passed as a function, remember, whenever an array is passed as a function, it is passed by value. It is passed by value. Now, there are two things over there. You already know, whenever a function is called, it's passed by value. Okay. So if you are having an entire array that is passing by reference over there, so what you are doing over there, and you modify that array inside it, supposing you put it a0 equal to 100, so what will happen, and you will bring it back over there, and you again have it modify 31. So this one will be changing that array value, because you are addressing that array over there, so you are having that array over there. Then afterwards, supposedly you put over here just one element of an array. Remember one thing, if you are putting an element of an array inside the function, that will be just passed by value. But if you are putting the whole array inside it, then the whole address memory locations of that array are being changed. So this is a totally different thing from the previous one, if you remember it. The variable was passed, you just take the copy of the value and you do whatever stuff, plus minus whatever. But when you are talking about an array, and if you are just passing on the element of that array, then that will be just by value. But if you are sending it the whole array over there, which is ARR is the array name over there, then when it will be returned, that array will be changed over there. Remember, this is something very important, because array are memory locations. They are memory locations over there. So this is passed by reference, because the reference is the memory location over there. So passing the entire array changes the effect original. But when you are passing a single element of an array, maybe like first element, second, third, fourth element, it does not change the original, or it does not affect the original over there. Then I guess using constant, I have already used this constant word. Function cannot modify the array. Now, whenever you are using the word constant, I guess CONST means constant. This means that when you are passing the whole array, you can't change that array, because you want to protect it. For that purpose, whenever you are defining a function, you have to tell that this is a constant. So CONST, which means that this parameter inside this function is always going to be constant over there. So again, you are, when passing on this data, even if you print it, this cannot be modified. You cannot modify it. It will be a compile error, because here this is constant defined over there. And I guess now you are getting the point why we have used it as constant, because here already we are not doing anything inside for the array. We are not changing any value of that array, but still over here, this is constant, and this is telling you that, okay, you can take the whole array, but you cannot change its value. So that's why this word const, we will use this constant value a little later on also in variables case over there. But here at present, when you are using the word constant, this means that you are protecting the arrays to be passed on as a parameter inside functions, and this will allow not to modify. In fact, this will not allow to modify your arrays over there. So it's just going, you can print off, or you can do the sum or something like that, whatever you want to do it, but you can't modify it over there. So this prevents accidental modifications, and it makes the code safer and clearer, and documents that function only reads the array over there. I hope this is a little not overwhelming for you, because it's a whole new topic, arrays over there. Next part, I'm going to start with the bubble sort. I guess this is enough for today. And for bubble sort, Just to give you an idea, if you have an array 5281, now you have to do the sorting. Sorting means that one is going to come in the first position, then two, then five, and then eight. So what is bubble sort? Just to give you a little idea in just like 1 minute, bubble sort means take the two adjacent elements, whichever is the smallest, move it first and five. So you will take this five and two, you take this one, five and two, okay, two is smaller, so two will move over here, five will over. So this will become 2581. When you have 2581, then you have 2581, you see, okay, the next one, five and eight, oh, okay, five and eight, they are okay because 5 is smaller, 8 is bigger. Okay, no problem. So this will remain the same. Then it goes down to 8 and 1. For 8 and 1, okay, this is wrong. So 8 will move over here, 1 will move over here. So this will have now changed to 2518. Now again, this will go on for 2 and 5. Again, this is okay. Then 5 and 1, again, this will go off. So this will be now 2158 over there. And this process will go on and on until and unless at the last you will have 1258. This type of sorting where you are taking two adjacent elements, checking out which one is smaller, which one is larger, rearrange them. The lower index has to be the smaller one, the higher index has to be the uh, larger one, and in this way you move on and on and on again and again, and then this way you can sort. Now this is something very easy way, but this is only practically viable time wise and processor wise for smaller arrays where you have like something 10, 20, 50 maximum. But if you have a longer array, maybe something 100 plus or 200 plus, then it's a big problem because then the number of iterations becomes much larger. So this is something very important. So we'll come back to this in the next part. We'll start with this bubble sort and all that, and we will talk about the linear search as well if you want to find out an element over there. And then we are going to talk about the 2D arrays, because up till now we have been talking about 1D array up till now. Then we'll talk about a 2D array, which is also actually a matrix over there. And then afterwards we have a lot amount of problems over here in this chapter, and then some common mistakes which we are going to talk about in this chapter. I hope you have got what we have done this in this part, and in this part we have done this. Kindly go through this one, the exercise questions and this figure over here, or in this type example, it's exactly the same thing which we have done in the slides over there. This is also exactly the same thing. You are having 2 plus 2 into j, and this is also we have done just once. The sum of the array, you are having the sum. So all these examples are available. You can download this from the link and below this link of this video. So I hope you have got it, and thank you. Let's meet in the next lecture.